In this lesson, we are going to cover the following topics. First, we will go through the general Maven project structure. Then, I will provide overview of POM, which is the pom.xml. As a part of this pom.xml related concepts, we will understand Maven Coordinates, which is very important, and packaging. I will also explain the concept of Super POM, which would be very important in this context. We will explore Maven Dependency and Dependencies Scopes. It is one of the very important features of Maven, followed with Maven Repositories, Maven Properties, and then I will explain all the concepts which I have discussed with a real-life Maven-based Spring Boot application example. Let's get started. A Maven project structure, the standard directory layout looks like this. Suppose this is the root. Under that, you have two things. One is the src directory, the source directory, and the pom.xml. Under source, there is main folder and test folder. Under main, you have two folders, Java and resources. Similarly, under test, you have Java and resources. As you know, main is for mainly application codes. Under Java, I will have all my package structure, Java source code. Under resources, I can have my application properties and other resources. Similarly, under test, under Java, I will have my test code, the JUnit code, and also similarly testing related files I can keep under this resources folder. Now, this is the standard structure, but when I run the Maven commands like mvn compile, mvn build, mvn install, and I want to generate some packages or artifacts out of the Maven project, then there would be a target directory created under my project. This is the target directory which is created under root. Under target directory, there would be two folders, classes and test classes. Classes basically contains the class files with respect to the source code I have under main folder under this Java directory. Similarly, test classes would be containing the class files associated to the unit test case classes, which is under test Java. Now, when I run relevant Maven commands like Maven package, Maven install, and any artifact is generated, that would be generated under this target folder. So, depending on my packaging type, it could be war, it could be EAR file or jar file. So it would be under this target folder. So target folder is an important folder where my generated classes are there under classes directory and test classes directory, and ultimately directly under this folder I would have my generated artifact like jar, var, EAR, etc. Now this layout I have explained for a general Maven project. Case to case basis, there would be some variations. If you go to this particular link which I have shown here under this Maven website, you can see this standard directory layout. It may vary from project to project. For example, on the top you can see the common structures, right? Source, main Java, source, main resources, etc. But for web applications, there would be additional folders. If you can see over here under src main web app, I have web application sources, then followed up with the test sources and test resources, which we have already seen. So depending on various kind of projects, this standard directory layout would have different directories, but in general, I have explained the general project structure which are most commonly used. Now let us discuss the project object model, the pom.xml, and the Maven coordinates. POM or POM stands for project object model. It's an XML representation of a Maven project written in a file called pom.xml. This is the heart of Maven actually. So in a POM file, there are certain minimum requirements. There would be certain XML tags which has to be present there. It starts with project, which is the root. Then I would be having model version. It should be set to 4.0.0. Then comes this group ID, artifact ID, and version. Group ID, it is generally the package structure that the project contains. For example, in Apache projects, the group ID is generally the org.apache. That is the package structure, and it would be their group ID as well. Artifact ID, it is basically the file name that is going to be produced when you generate any artifact, which is jar or var or ER. Whatever artifact ID you would be giving, that would be contained in the artifact name. So often we keep it as the project name. Then comes the version. This is the version of the artifact under the specified group, meaning in a project there could be multiple versions. So this version ID is used to maintain the version. Now, if I try to show you a minimum pom.xml, if you can see over here, I have this project tag, I have the model version which I explained like 4.0.0. Then we have group ID, artifact ID, version. What is the group ID? It is basically the package name. What is the artifact ID? It is the project name. What is the version? It is the version of the project. As simple as that. Now, if I go back to the slide, this group ID, artifact ID and version, GAV, these are together called the Maven coordinates. These three are very important to locate a particular project in a repository. A repository is basically a server or location in internet where different Maven projects are there. So if I want to identify or locate a particular Maven project, I need this GAV. Maven coordinates are basically a combination of these three. It's a very simple concept, but a very important one. Apart from Maven coordinates, there is another important thing which is packaging. It states the file type of the generated artifact like var, jar, etc. When no packaging is declared, Maven by default would produce a jar file. So the pom.xml that we have seen earlier, if I go back to the slide, here you can see no packaging is defined. Now if I run standard Maven commands to generate any artifact like mvn package or mvn install, it would create a jar file because I don't have any packaging declared. Now let's look at some real life examples and let's understand this GAV in more detail. If I show you some common Apache Maven based open source projects from Apache, let's type Apache Commons Maven. Click over here. Let me open any one of them, maybe Apache Commons Lang. So if you see over here, these are different versions. This 3.14.x, if you see 3.14.0, 3.13.0, these are different versions. If I click over them, select Maven, you can see there is a tag called dependency. What is dependency? We will discuss later. But under dependency, you can see group ID, artifact ID, version. So for this Apache Commons project in the central repository, if I go back here, if you see, there are multiple versions are there. And if I need to locate this project, say in a particular project, I want to use this Commons Lang project, I need to specify a version, I need to specify a group ID and artifact ID. In that way, I would be able to use these projects. Now, how I would use these projects, we will explain. Now let's understand the Maven version with some additional details. As I mentioned, the version number is used by Maven to track different builds and releases of the project. It's also essential when other projects depend on your project, as it helps in specifying which version of the artifact they should use. Suppose I have a project, I have a version. Now others are using my project. So if my project have multiple versions, they have to mention the version they want to use. So it's an important feature. Maven does not enforce any specific versioning scheme, but a common practice is to use semantic versioning, which follows the major.minor.patch format. How it works? Let me show you. Let me go back to the Apache Commons website. Here you can see this 3.14. 3 is major, 14 is minor. Under 3.8.x, you can see there was one patch which is 3.8.1. 3 was major, 8 was minor, 1 is patch. But in the versions like from 3.9 to 3.10 or 3.11, there was nothing required. That is why we don't have any patches over there in the other versions. But under 3.8.x or 3.3.x, you can see there were two patches, 3.3.1 and 3.3.2. Additionally, Maven projects often use snapshot as a suffix for versions under development. Now, whatever we saw for that Commons project, that was a release. It was not under development. It was a final version. But when there is development going on, Maven projects use this -snapshot instead of this 3.8.10 or etc. So it allows for continuous updating of the artifacts without the need to increment the version number after each update. Now the snapshot versions are mutable, meaning that they can change over time. They are typically named like 1.0.0-snapshot. So when we develop these projects, we don't change the versions multiple times. Instead, we use snapshots. When it comes to final releases, then we apply this semantic versioning in general. Following a certain key elements, some of them we have already discussed like model version, group ID, artifact ID, version, packaging, etc. There are some important aspects we will discuss like properties, dependencies. There are certain other key elements we will discuss in this specific lessons, and remaining ones we are going to discuss in the upcoming lessons. Now there is an important concept we should understand, which is Super POM. We have already seen the general project structure for Maven projects. But pom.xml assumes certain default values for many important parts, like src main java is the source directory. We discussed that. src test java is the test source directory, and so on. But how it understands that? I have created a project. There are different directory structures, but when Maven would run any command, say to compile the code, to generate the artifacts, etc., how Maven will understand? So in this case, the concept of Super POM becomes very handy. Like all Java objects, they inherit from Java lang object. All pom.xml files inherit from a base Super POM. Its location is in your Maven installation directory under lib Maven model builder, your Maven version.jar. There under org/apache/maven/project pom-4.0.0.xml. So your Maven installation directory would have a jar file. Inside that jar file, there would be a pom-4.0.0.xml. This is a Super POM. And this Super POM will have certain values defined which Maven would use for certain default values. Now these values could be overridden in your own pom.xml. So by default your pom.xml would use the values from the super pom.xml, and if required you can override those values in your custom pom.xml. Let me show you one sample super pom.xml from the Maven website, and I will also show you the super pom from my Maven installation directory also. Now here in the Maven website you can see this particular URL, and here for Maven version 3.0.4 they have shown a super pom. What it contains? Model version, by default it is there. It has a repository. You can see the value of this URL, which is http://repo.maven.apache.org/maven2. Now what are repositories we'll come to know in this lesson when we discuss dependencies, but this is the default value which is there in superpom.xml. If I scroll down, this is important. Under build, you can see this is the directory. If you see this particular notation, when we explain Maven properties, we will come to know. But this is the project base directory /target. This is my directory. This is my output directory, which is classes. So if you notice here, under my project.build.directory, I have defined this is my directory. Now the output directory would be under this /classes. The final name would be like this. Test output directory similarly would be under test classes. So all these default values like source directory, you can see it has given that it should be the project based directory. Under that src main java. Test source directory should be src test java. So this all default values are defined over here, and when Maven runs its commands, it uses this default values unless we override in our project specific pom.xml. So that is the way super pom works. Now let me go to my Maven installation directory. Here I am under my Maven directory. Let me click this lib directory. So this is the file I need to extract. Let me extract this. This is the directory where it got extracted. Let me go inside org.apache.maven.model, and here I have this pom.xml. Let me open it. Now here you can see similar values are there which I showed you from the Maven website. Now as it is my local installation and my Maven version is 3.8.6, few things may vary, but generally these are all standard values. They don't change often. Now we will discuss dependencies, which is a very critical aspect of Maven. I will have separate lessons on dependencies, but here I will provide an overview. A Maven dependency is an external Java library or module that any Maven-based project requires to compile and run. This dependencies sections allow us to define external libraries and their versions required by your project. Maven will automatically download and include these dependencies during the build process. So let me explain this with an example. I have created a sample project for you in GitHub. Let me go to that project. So in GitHub, I have this particular project which is under github.com/j2expert2015 sample-maven-app. If I go to this pom.xml, here if I scroll down, you can see there is a section called dependencies, and under that there are multiple dependencies defined. If you notice here, I have this group ID, artifact ID, version, etc. defined. Now this version, if you see inside dollar and then curly braces and all, this value is already defined over here. I'm going to cover properties later on, but if I scroll up over here, we can define different properties in Maven. These are user defined properties where I can place certain values like spring.boot.version over here, and I can replace these values over here so that I don't have to mention this version in multiple places. I define a value and I use it all across the pom.xml. Anyways, so coming back to dependencies, here what we are doing, we are mentioning this is the group ID, this is the artifact ID, this is the version. So I am dependent on this Spring Boot libraries or jar files. What I am telling Maven, you download these jar files from my repository, from a particular location, because my project needs these jar files, needs these libraries. So here we are defining all the dependencies, all the libraries that we need, like Spring Boot Starter Web, Spring Boot Starter Data JPA, Hibernate Validator, etc. So this POM dependencies can be defined with a group ID, artifact ID, version as I mentioned, and scope. What is scope? I'll discuss. Now this group ID and artifact ID identify the dependency. The version specifies the specific version of the dependency that is required, and the scope specifies the context in which the dependency is required, like the library that I want to download, whether it is needed for my code compilation, code test, or I need it to run my project. For example, if I have a dependency for Spring Web or Spring Data JPA, I need to compile my code and run as well. But if I have a JUnit dependency, it would be for test purpose only. Let me go back to the pom.xml once again to show you. So here, if you see, by default, only the GAV, group ID, artifact ID, version is defined. Scope is not mentioned, which means the scope is compile. So I need the library to compile my code and run my application. But if I scroll down for Spring Boot Starter Test, you can see the scope is test. I need this unit test related libraries only for test purpose. Similarly, for this database related jar for H2 database, it is runtime. I don't need it to compile my code, but while I am running, if I need to connect with my database, I need this library. The dependencies that I have declared within the pom.xml, they are called direct or primary dependencies. These are the dependencies we specify in our pom.xml. They are directly required by your project. Apart from direct dependencies, there is an important concept called transitive dependencies. When your direct dependencies have their own dependencies, those become transitive dependencies of your project. Maven automatically resolves and includes these in your project build. For example, suppose your project A, includes a direct dependency on library, which is library B. If library B in turn depends on library C, then library C becomes a transitive dependency of your project. Let me explain this with an example. So here I have this Spring Boot Starter Web or Spring Boot Starter Data JPA. These are my direct dependencies. But suppose Spring Boot Starter Web, that requires certain libraries, and for that it has some dependencies. So those dependencies are transitive dependencies for me. Now that is the power of Maven. I depend on somebody and somebody depends on somebody else that Maven would take care of. I don't have to go to those places and download them. So I want to explain this with a sample command also. What I'll do, I'll download this project. Let me download that from here. Download zip, extract it somewhere. I'm just renaming it, removing this -master. Now I am inside my sample Maven project directory, which is here. And I'm going to run one particular command. So from command line, I need to go to this directory and run this particular command. So I'm going to run this command mvn dependency :tree. Let me scroll up a bit. Here you can see there are different levels. This is the first level, this is the second level, this is the third level, this is the fourth level. Now at the top we have the direct dependencies, which is Spring Web. Now Spring Web in turn depends on this Spring Boot Starter. That one depends on this Spring Boot. This internally, these are at same layer, but this Spring Boot Starter logging is another dependency under Spring Boot Starter. This logging in turn depends on Logback Classic, Logback Core, etc. So these are transitive dependencies with respect to my project. Similarly, if I scroll down, this is the Spring Boot Starter JPA. This is my direct dependency, but this dependency has further dependencies, like it has dependency on Starter AOP. This one in turn has dependency on Aspect JWeaver, etc. But handling all this is taken care by Maven. Now we understood dependencies at a very high level, but when we discuss about dependencies, concept of Maven repository is very important. So in case of Maven project, I have my laptop or desktop. There I have written my code. I have a sample pom.xml and maybe I'm running standard Maven commands like mvn compile or mvn package. So what will happen if I have any dependencies written inside my pom.xml? First thing, if in my local repository those dependencies are already there, those jar files are already downloaded, Maven will look for those locations. These locations are basically c:\users your username /.m2 folder /repository if it is a Windows system. For Linux it is little bit different as I have shown here. So what Maven will do, first Maven will go to this local repository and check whether the dependencies are already downloaded by Maven over there or not. But you can understand very easily, if I am running this Maven compile or Maven package command for the first time, then there would be no local repository, right? Nothing would be created. But if I run this Maven compile or Maven package, then this local repository would be created and the dependencies would be downloaded there. Otherwise, I won't find anything. So in case I run this command, it will first go to this local repository, search for it. If it finds, fine. But if it does not find, what will happen? It will look for a remote repository. Now, remote repository are organization specific. In your organization, you can create a server, you can place Maven files over there and create a Maven repository which is used by organizations. That's not a common practice. In general, when we develop in our laptops or personal desktops, we don't use remote repository. If you are working for a company and they create a Maven repository, you can use it as a remote repository. Otherwise, generally what we do, we use Maven central repository, which is https://repo1.maven.org/maven2. So what will happen when I run this Maven compile or Maven package, this command for the first time, it won't find anything in the local repository, right? It would go to either remote repository or Maven central repository. It would download all the dependencies from there, and then once it downloads, I have all of them in my local repository. So next time if I run this Maven compile or Maven package, I will directly get it from my local repository. In that way, local repository will act as a cache for me. Now, how would Maven know that, okay, this is the location of my central repository? Here also, the concept of Super POM is very important. If I open the Super POM once again, you see over here, by default, it is showing this is the value of my repository under URL. Now, if I have a custom remote repository, I need to include those credentials, those details over here. In that case, what Maven will do? Maven will look into that remote repository instead of the central repository. So, as I explained earlier, how this dependency resolution works. Suppose I have a project. I have my GAV or Maven coordinates defined. I have my dependencies. Now there is a remote repository or a central repository. There I have different projects, like I showed Apache Commons project, right? It is there. So what will happen? I have my dependencies. In the dependencies, I have the Maven coordinates defined. So it will read that and it will go to the specific repository, and from there, with the help of this group ID, artifact ID and version, it will locate those projects and download the dependencies. Similarly, if some other projects are referring to me with my Maven coordinates, they will look after me with those Maven coordinates and search me. If my project is in my local directory, it will look for local directory. If my project is hosted, if my jar files or artifacts are hosted in some server or publicly, it will look out for the public repository from where it will try to download. So this is the way the dependency resolution works. Now I'm going to cover this dependency scopes at a very high level because I'll have a separate detailed video on this. So scope attribute is used to control the visibility of the dependency. Compile scope is there. It is the default scope. If I don't mention anything, the scope would be compiled. It is required to build and run the project. Provided scope is used when the dependency is provided by the target runtime or the container and it is not needed at compile time. For example, in a web project, if there is servlet API or JSP API, we need them at runtime. We don't need them at compile time. So we generally make them provided. Runtime and test we already discussed. So runtime scope is used when dependency is needed at runtime but not at compile time, like the database jar we saw for H2 database. Test scope is used for dependencies that are only required for testing, like JUnit scopes or Spring Test Starter dependencies, etc. System scope is used when the dependency is not available in a public repository and must be manually installed on local system. Suppose I have a jar file or artifact, I need to use it as a dependency, but it is not there in central repository or my remote repository. It is maybe in my local system. Then using system scope we can use that. Import, it indicates the dependency to be replaced with the effective list of dependencies in the specified POM files. So import scope, it is also rarely used. Suppose I have a project and I want to use the dependencies in another POM project. In that case, import scope is used. So apart from dependencies, we are going to discuss about properties in pom.xml. So Maven provides properties which are basically placeholders that can be used inside pom.xml file. We saw it earlier. Maven properties are referenced in pom.xml using this $braces property name notation. Now there are two types of properties, implicit properties and user defined properties. As we already went through the user defined properties earlier, let me explain the user defined properties. So in a pom.xml file, Maven allows you to declare custom properties with this particular properties tag. This is especially useful when Maven has a lot of dependencies and you need to know or change a version of a particular dependency. So if I open this pom.xml which I showed you earlier, I have this properties, I have this values defined. So this version I'm mentioning here and I'm referring at multiple places like this one. Tomorrow, if I need to change the version, I just need to update it at one place and I don't need to change at multiple places. So that's why I have created it as properties. These are very common things like Maven compiler source, Maven compiler target. So this Maven compiler source mentions the version of the compiler that is used for compiling the code. Similarly, the Maven compiler.target, this mentions the expected Java version for this compiled classes. Apart from user-defined properties, there are implicit properties in Maven pom.xml. These are available by default to any Maven project. There are many types of implicit properties like the following. Project properties. We can use this $project.syntax to reference the value of the element in the POM file. For example, project.version will return the value of the version tag of the pom.xml. We can also refer to environment variables through this particular notation $env dot the variable name. For example, if I want to refer to Java home or path, it could be $brace env.javahome or $brace env.path. Settings properties. Prefixing a variable with settings dot will return the value of that element in the settings file. In Maven, we use the settings.xml. So whatever values are defined over here with this particular notation, we can access them. For example, with this $brace settings.offline, we can return the value of offline which is defined in the settings.xml. The last one is system or Java properties. Any property available through this system.getProperties method in Java, we can access them. If we write like $brace java.home, then we can access the home variable. So that is all for now. We will discuss further important Maven concepts in upcoming lessons.